good tech, man. We've just been watching all the scores of the videos. Very good.
Last few years I was contracting for utilities, and it was fun. It was fun times. And then one we finally finished. Oh no, I did another 6 months.
Okay, our next.
Alright, but then I lose this time.
Mike. Okay, I think I've got the microphone on now. Our next presenter is Alex HB9DRI. Alex was born in Lima, Peru in 1964. Kid, my goodness. He studied communication sciences at the University of Lima, Peru, later graduating as electronic engineer and obtaining a postgraduate degree as an IT engineer. That seems to be a common thread for RF guys going into IT. I didn't qualify. Alex has worked in the telecommunications field for his entire life, installing the first analog cell telephone network in Peru in 1990. He developed the first radio network. I can't pronounce it, forget it. You want to try that?
What's that?
What is that? How do you pronounce that?
Radio goniometry system for military applications.
Okay, all right. He designed that network for the Peruvian government to fight the communist terrorists in the 1990s. He's worked in the Amazon rainforest installing VHF and UHF telecom for oil companies, installing the first 64 kilobit VSAT systems at oil wells. He's lived in several countries and continents, and since 2000 has been based in Switzerland, operating his HB9DRI. He's an active member of the HB9Q group. He's married to a Swiss national and lives in Lucerne area. Alex owns Link RF, through which he has produced countless pieces of equipment for EME and radio astronomy. The renowned IQ+ was launched 15 years ago, and he has continued to innovate and create ever since. Currently, he is modernizing his creations and hopes to expand the product line to 10 gigs, where it will soon have many surprises. So please welcome Alex, HB9DRI.
Okay, good morning, friends. Thank you, Barry. It's a pleasure to be again in the EME conference here. Okay, let's go straight to the presentation. This is regarding the latest radio I am ready to place on the market for a limited numbers. Is the IQ+Pro, and it's the heritage and it's done on the lineage of the IQ+. Just before I start, I want to tell a little bit the story of the IQ+. It was running around 2008, 2009 when Joe Taylor was very active introducing JT65, when MAP65 became version 0.3. And at that time we was running the WSE boxes, receivers from the live Osplin Sugarman 5BS set to do this adaptive polarization, but it's nothing else. Instead of rotate physically a huge array, you create a weighted sum of two signals, horizontal and vertical. You put in the computer and the software make all the mathematical calculations to optimize the angle reception. We adopt this one in HB9Q. We bought the WSE converters, huge boxes, expensive, around $5,000 the set. And we set up everything on our dish, in our 15-meter dish, and we start dealing with LinRad and MAP65. And we've been beta testers of Joe Taylor for MAP65 for almost 2 years, until version 1.0 became available. And I remember in a conversation with Joe, told me that, okay, you are doing a lot of experiments. Do you think it's possible to have other kind of hardware, more friendly, more cheaper, more small than the WSE converters? that day I embraced my personal, as a personal challenge to build something. That was the born of the IQ+ project, and a small box. The IQ+ project was sold for the last, I would say, 15 years, more than 400 units in VHF, around 100 units in 432, and around 20 units in 50 megahertz. And I'm very happy to say that, thanks God, I was able to design the IQ+ Pro and present the creation on Cambridge 2012, that means many years ago. I helped to boost this democratization of the hobby, giving access to those who are not able to run more bigger antennas, or they don't have the capability to learn properly CW or whatsoever. That is a little bit the story. Well, now the introduction is happening now. We will talk about signal polarization on the EME path. Just to make a small recap, I don't want to reinvent the wheel here. We have many other presentations done in the EME conferences regarding that. I will talk about what was the IQ+, because the concept is exactly the same. I will present the IQ+ Pro, the evolution of the IQ+, and we will do a practical session. I was able to build a piece of software I call the IQ+ Pro Simulator. I will bombardier yourself with CW signals in a few minutes, and this software is capable to rotate the polarization of the signal we are receiving. It's capable to introduce all kind of man-made noise, all kind of propagation problems with fluttering, vibration. We can make a QSB deep up and down, and we have a lot to play. The software is in beta version. It has a lot of bugs. It's available on my homepage to download for free. You will see later the link. That means after I finish the formal part of the presentation, I will stop around 15-20 minutes in the software, and you will see what is, or how as a clean sound CW signal arrives to your antenna without considering propagation problems or man-made noise problems. And we will start to degrade in the signal until we will lose the signal. And we will start to rotating the antenna electronically, and you will see the effect of this Faraday rotation. And then we will talk a little bit future plans, and of course, the properly Q&A. In 50 megahertz, 144 and 432, waves change, polarization will propagate on the free space. And this rotation creates this mismatch. Polarization creates an error, what is immediately translated in losses directly on your signal chain. As you see, it starts to become critical at 45 degrees. When 45 degrees mismatch happens, you already have 3 dBs signal loss. If your station is a marginal station, even at 10 or 20 degrees depolarization, you already lost the signal. For years, EME people, especially in 432, compensate this one, rotating the whole array. It was Ian Wright, I don't remember the G3, he built one of the most fantastic rotating arrays to compensate this, but it was a mechanical solution. And many others follow, and it was a success for many years. This is in the 90s around, okay? Well, the idea is exactly rotate this polarization, but in an electronic way inside your computer, okay? And this is totally valid for CW, SSB, or JT or whatsoever. It's independent of the mode you use. The change of the polarization has 3 factors. Existing one fixed component, one is the spatial rotation, and the spatial rotation is something we cannot change. That means, depends where you live. If you transmit here horizontally, this side of the earth, the signals will arrive vertical in the other side. And Ian White in his homepage has a very lovely table showing you when east listen west, when both listen, etc., depending on the depolarization or the polarization error you have on the moment you are doing the communication. This is the fixed component, okay? Then this geometric rotation or spatial polarization depends on the moon position, and it also varies depending if you are in moon rise or in moon set. And that means this fixed element, we can fix only moving the station to another latitude or another continent, has also a variable component, and it has to do with the moon calendar according to how the moon is moving and how the moon respect to the Earth is appearing. In some bands, this Faraday rotation is bigger, and also this problematic is more easy to detect in the lower bands. 50 megahertz, I operate 50 megahertz a lot from Namibia many years ago, and you have depolarization changes, but 20, 30, 40 degrees in 10, 15 seconds, okay? Very fast. The depolarization is 74 times faster in 50 megahertz compared with 432, and 9 times faster in 144 compared with 432. And in 432 you have the famous deadlock, when the polarization jump in an inconvenient polarization for your station for hours. And that day you publish in the reflector, today we have bad conditions. No? That is not about bad conditions, it's just because you are with the wrong card, you don't have the A's. Sometimes the polarization locked for your convenience in the right angle for your station when you are working Europe versus America, for example. The variable and unpredictable Faraday rotation. Here, we need to understand that this is variable because we cannot predict how much Faraday rotation will happen. Faraday rotation happens when the signal traverses the ionosphere and interact with electric particles on the ionosphere. Also, when the signal bounces off the moon, immediately in your polarization. When you transmit with your feet in your dish, as soon as the signal arrives at the bottom of the dish, change polarization. You transmit horizontal, it goes out not horizontal from the dish because bounce, goes vertical, travel, bounce on the moon, again back horizontal, and arrive in the same polarization you start. That means every time the signal bounce, change polarization. But in between this electric magnetic field of the air and these electric particles disturb and create this Faraday rotation. The lower the frequency, the faster the speed. Okay, that is clear. Also, that makes what I was telling you, the rotation is 9 times faster in 144. In 144 compared with 432, and in 50 megahertz is 74 times faster. That means existing many factors when you go very low in frequency. To find Faraday rotation, the IQ+ was created 15 years ago, and it was a success. It boosted the development of MAP 65 from version 1.0 to 3.0, 3.1 today, I think so, because it was the only available hardware in the beginning. Later on, we can talk about other alternatives quite technically are not compatible with the IQ+. The EME, the IQ+, okay, the first functional prototype was in 2010. This is 16 years ago. Inspired on the WC radios from life, I already say that. It was the first massive real option for MAP65 and JT65 boosting Joe Taylor protocol on the lower bands. It was the real game changer for a lot of people. More than 400 units sold in different versions. But what about the reality? What this small radio can do? And I would say it can do almost everything you need from the perspective of the radio and the Faraday rotation. John over today already showed us what is about the antennas. And when you're starting to collect all this improvement in the antennas, in the radio, then slowly you are approaching the top-notch performance you need for an EME station. To fight Faraday rotation, the IQ+ used two Gemini RX channels and existed a sine qua non condition for diversity or adaptive polarization. The local oscillator must be shared exactly the same in amplitude and phase in both channels. Any difference, any coax a little bit longer or shorter, any difference on the angle will affect the way the software later create the weighted sum of the two signals. Each channel is attached to a multiple antenna, B&H, okay? Some people today, for example, they don't run an adaptive polarization, but they run two receptors at the same time. And they have two decoders at the same time, one in B and one in H. Because remember, 45 degrees difference when you have both will be just 3 dB penalization. As soon you started to go more than 45 dB, is the other polarization starting to dominate. That means with two instances, with two radios receiving simultaneously, you can do a lot. Well, when you do map 65, and you do coding, and you do CW, and you are able to rotate electronically the antenna, it's a tremendous advantage because I don't know if somebody remember when Live took a Mi-5 BS win CW contest in the 90s. It was the only guy who was surpassing the big monster antennas. He was testing his first adaptive polarization with Lindra at that time. And he was able, with a modest four jaggies, 4 cross jaggies, to simply kill everybody. That means he demonstrated in practice the utility. When the signals are digitized and passed to the PC, Lindra and or map65 create this weighted sum of the orthogonal signal, extracting the correct polarization with the best polarization angle. That means the stronger signal strength of the signal. And that creates a very important thing. That outsources automatically one big headache you have on the station. That means you don't need to take care anymore. We are in the south hemisphere, in the north hemisphere, in the west, in the east. This one come here or there. You don't need to see the calendar. Just, even if the signal comes in the wrong polarization, this weighted sum mathematically will do all the sum and create the stronger signal. All the theory and all the mathematical formulas for this are very well explained in Lindra homepage. What is not the scope of this presentation. Really complex, and if you want to drill, I recommend go and search for that. Literally, and this is what I was telling you, rotate the antenna digitally instead of physically rotate the entire array. So most of the times impossible, especially in 144. I don't recall nobody who built a 144 rotative array.
B7 VQH.
Yes? Oh, well, that's good.
Goes to KA9 in the 1980s.
Yes.
There were about 20 of them.
Okay, well, imagine. But rotating physically these monster antennas is a real mechanical challenge and also costly. That is the standard structure of the IQ+. That means you have a vertical and horizontal antenna. The local oscillator is shared by both RX ports, and the I and Q is injected in the PC using the famous Delta 44 card. How many of you use this? Remember, it was a PCI card, I think so. Not anymore available for the main boards. It's a memorabilia device. And the IQ+ used the PC audio card to do the ADC conversion. Clever, but not in an efficient way, because audio cards are for music. And they are starting to roll down the performance after 17, 18 kilohertz. That means you sample 96, that means plus minus 48, but the last 20 kilohertz of your bandwidth in every corner, the card doesn't perform good. Yeah, that means it works. Everybody used audio cards for years, but as I said, audio cards are for music. Later on, after 4 different versions of the IQ+, I created a UADC4. The UADC4 was the first ADC dedicated for 0EF receivers and surpassed the limitation of any other audio card on the market. I sold 50 units. I think so, existing 3 or 4 damage, probably, lining or something like that. And the rest, I don't produce anymore. These ones, I always say I will produce a limited number. That means today, and the UADC4 can be bought for 20-30% more than the people pay, because people is looking for this kind of ADC. And it has a resale price higher. Well, that is the IQ+. I remember this photo. That's 2010. You can recognize behind you have the 2 input connectors for the 2 antennas. You have the mute to mute the IQ modulator, power to control the local oscillator via the PC, and the I and Q outputs with RCA connectors. Pure audio, lovely, simple, a mess of cables inside. I did this time independent boards. This was a prototype. You can see the difference. This was the production, only 2 cavities, input and output. This was a 3-cavity input, but I didn't reach any benefit, any additional benefit using more expensive. That means you can recognize here the MMIC amplifier, the IQ mixer. This is the local oscillator injection, and this is the post-conversion amplifier to go to the audio card. That was the IQ+. 2 of these connected. This is the local oscillator. It was an SI 570 with a very low phase noise, not GPS locked. Later on, a lot of people removed this one and installed a Leo Bodnar. Okay? Oh well, I don't know why. But anyway, I just one thing. Leo Bodnar makes an upgrade for the latest devices. I measure the phase noise of all these devices and they are respectable. Okay. That was the structure of the LT5570. This is a 20-year-old chip. At the time I built it was 10 years old. Okay. This is how it works internally. That means the signal is accoupled to the 2 mixers. And the curiosity here is the local oscillator was 2 times the working frequency. Don't ask me why.
Easy.
Huh?
It's to produce the IQ for the
No, because you are multiplied by 2, but then here you are divided by 2.
You divide by 2, but you produce I and Q digital streams
Yes,
that go
yes.
to the mixers.
But the next generation doesn't use a double local oscillator. Yeah? Looks like it was more related to phase noise probably, because at the moment they divided internally, also they divide and they down the phase noise. With the last 5 years, many SDR radios capable to do diversity or adaptive polarization appears. They have fancy software interfaces that SDR radios where they use a very native software. And they promise sampling on the antenna, something cool, but not really. And they auto-denominate themselves as a pure SDA radios. I disagree, because they are not totally on that when they are applied for moon bounds. But, as I said, the limitation on the bit sampling create many problems on these radios. They do a lot of tricks of decimation. They do a lot of trick to down the noise floor in a synthetic way, but at the end, you finish with ADC's maximum sampling at 16 bits. Those chips capable to do direct sampling at more than 60 bit in 144 megahertz cost thousands of dollars. And they are mainly reserved for military applications. We don't have access to that technology. That means we use ADCs where they sample up to 50, 60 megahertz, and then you add a transverter. You add a converter. That means you, in one side, you criticize the IQ mixers, but in the other side, as soon as you have your SDR and you put a mixer to go up to the frequency you want, all the promise of sampling on the antenna is vanished, creating the same problems IQ mixers create. This table shows you what is the expected maximum dynamic range you can reach, depending on the resolution of bits of your ADZ. The numbers, and a rule of thumb I learned is that numbers kill 20 dBs, and that will be the real at the end. That means in the case of you use a 24-bit is theoretical 146, but due to the integration of all the other stages and the noise figure, the internal noise figure of the whole chip, this 146 down to around 120, 125 maximum with a single chip. Another technique is to use 2 ADCs in parallel, 4 ADCs in parallel. Every time you put two chips in parallel, you increase the dynamic range and you decrease and you deep the noise floor. That means those radios, they give you 2 channels, but they are using 12 bits, 14 bits, 16 bits. They are good and they work fantastic. Don't mislead this part. They work fantastic in a calm environments, in places where you don't have so much interference. But when you are running in places with a lot of interference, then the shortage of the dynamic range and IM3 tolerance will start to pay a big toll on your signal. The IQ+ is a full integrated solution. And now we are talking about the IQ+Pro. You remember the IQ+ was several boards with a lot of IQ cables going inside. That was my first approach. Preamplifier, IQ mixer, post-conversion amplifier, ADC, and USB interface. Everything in one single motherboard. And these are the preliminary results from the first functional prototype ready to go. When the IQ+ saturates at minus 26 dBm, the IQ+ Pro saturates at 0 dBm. That is a 26 dB headroom between both modems. And that gives you a lot of power to fight IM3. The noise floor down in a bandwidth of 1 kHz from 122 dBm to 131. Normalize in a noise density at 1 kHz that represents minus 161 dBm per hertz noise floor. This is a tremendous lower noise floor, very difficult to achieve. At a spurious-free dynamic range, the IQ+ can arrive to 85 dB depending on the audio card you was using. The IQ+ Pro, honestly, I reach more than 100, but I keep my numbers very conservative. I can push this number 10 or 12 dB higher for marketing reasons, but I am honest. When other engineers they auto-denominate cynical, I auto-denominate myself an honest engineer. I will never increase my numbers trying to sell more with that. And that creates more or less 15 dB spurious-free dynamic range plus on the budget. That are the basic numbers. Of course, we can compare a noise figure, but as soon as we are using a mass-mounted preamp, that is irrelevant. That, for example, make another very important aspect. The IQ+ Pro could be an excellent radio for terrestrial contest, because the IQ+ Pro, the internal preamplifier, uses the LTC 6450, what we will see later. This is A latest amplifier used in high definition TV video devices, professional. It's bloody expensive, but I decided to use why? Because it has a 4+47 output IP3. It's a monster. That means if we remove the mass-mounted preamp, the IQ+ can tolerate even stronger signals. And that may candidate also to use the radio for terrestrial with a lot of stations around. Okay, do you remember how the IQ+ was looking? That was an IQ+, and today this is the IQ+ Pro. One single board, and I will explain stage per stage. You have two channels here. The multi-pin here is to allocate in the top an XMOS board capable to do the conversion of the ADC stream to USB and put directly in the computer using class 2 audio driver under Linux or a properly driver under Windows. And the left side you have the two inputs, the two channels, followed by bandpass filters. And a very clever modification I did is you have these two squares with holes to install a small elevated PCB. One of the problems I have with the IQ+ is more or less 20% of the people, by error, of course no intentional, they transmit 200, 300, 400 watts into the radio. Because they make a mistake in the sequencer or whatsoever, and they burn the internal MMIC. That means they need to send the radio to Switzerland when they are not capable to do microscopic surface mount repairs or find somebody, replace the PHA1 amplifier. Sometimes the bandpass filter was damaged also. That means in this case what I did is the expensive preamplifier is an external PCB just plugged. You can see here the pins, input pins, output pins, and DC. And everyone has his own power supply here. It comes from the top, and every radio will come with 2 extra boards. You know why? Because I am tired of repairing radios. That means, and just for a short period of time, for the cost of the external boards, I will have extra boards. That means, for example, I want to be honest, in HB9Q, the 15 megahertz setup, we burned the RX boards at least 10 times. Yes, and then we found a problem. We have an error in the routing between AC, DC, and HF and high frequency power cables. That means we have a big induction happening on this antenna, and we didn't understand. In 2 meters and in 70 centimeters, we never blow up, but in 50 meters, 10 times we burn the preamplifiers. And then I was up to here repairing this stuff. That means that is a modular part of the radio, because then you don't need to replace. Then you have a second set of bandpass filters, and then you have the IQ demodulators here with all the glue around. I want to tell you, to arrive to this PCB, we built 7 PCBs. And the previous doesn't work properly because you rotate one capacitor near the IQ mixer 90 degrees, you lose 2 dBs in noise floor due to magnetic influence between parts. And I don't have access to EMC software. I cannot do electromagnetic simulation because I don't have $25,000 to buy a license and learn how to use this software. That means it was a try and error. Later on, you have a post-conversion amplifier, a very low noise op-amp, and then later on you have the magic, the ADC. Quite is exactly the same ADC we use in the UADC4. This ADC sampled at 24 beats. It can do up to 385 kilohertz of bandwidth. Okay, it's not an ADC to sample in 20, 30, 40 megahertz because it will not be possible to be 24 beat. immediately the deep, we will down the value of the bits. And then you have another associated power supplies here, and this is the input for the local oscillator, a bandpass filter, and this is a mini circuit splitter where I split the signal 0 degrees, 3 dBs, 0 degree difference in both channels, and then IPEX connectors inject the local oscillator here. The complexity is to do this one properly was the first time I designed 4-layer. This is a 4-layer PCB. A nightmare. That means you need to define DC layer, you need to define ground layer, but ground layers you need to define too. You have analog ground layer and you have RF, analog ground layer for RF and digital ground layer for the ADC. If you don't, I want to show you, we have these resistors, are testing resistors to test, because you connect the ground layer, the analog ground layer, and the digital ground layer in one point need to be connected together. But only one point. These 3 resistors are 0 ohm resistors, installed randomly, and then I test which one produces the best results. And it's only one, it's only one position. That means this is in the final product you will not see these 3. And the size of the board is exactly the same size of a U86-4. That means this board will enter exactly in the same box of the IQ+ we have previously. It's not bigger. The density of components is very high, and it marks a really complex try and error when you don't have the full tools to do EMC simulation. Performance explanation. Headroom. Raising the saturation point from -26 dBm to 0 means the IQ+Pro can handle 26 dB stronger signals before compression. 26 dBs. How many? That means 30 dBs is a factor of 1,000, I think so. Okay? That means it's a little bit less than 1,000 times more capable to manage strong signals. And remember one thing, when you talk about software-defined radios, and even in the analog, people make an error thinking, oh, I have a signal close to 0 dBm, but if you have two signals, or 3 signals, or 4 signals, just 5 or 6 dBs away from the saturation, the signals start to zoom and start to raise the level of the ADC. That means you need not necessarily 1 or 2 signals on the top to saturate. You need maybe 5 or 6 at 75% of the tolerance of your ADC. They zoom and you enter in clipping immediately. And when you enter in clipping, you are dead. You will see in the demonstration. The noise floor. A 9 dB lower noise floor translates to almost 8 times better sensitivity in power terms, allowing detection of weaker signals without degradation. Let's take this with a pinch of salt. Remember, the IQ+ is not responsible to establish the signal-to-noise ratio of your system. That is established in your antenna. How good is your antenna? What is in front of the preamp? And how good is your preamp? What is down on that box on the top, what is achieved correctly or destroyed, cannot be repaired downstairs. And this will be part of my presentation tomorrow when we talk about preamps. Remember that part. What is destroyed in the antenna cannot be reversed and repaired. That means all those ones who installed bandpass filters after the preamp, sorry, big mistake. That's for nothing. That's just to see you are doing something, but in the real practice, you don't achieve any improvement. Spurious-free dynamic range, 15 dB, more spurious-free dynamic range means spurious components are 30 times lower. If you have a bandpass full of Vertis, with the IQ+ Pro, you will have much less Vertis, and much more room Of course, everything will depend on the neighborhood, on the area you are working. Okay. Performance explanation, we already talked. And as I mentioned, you see here, this is the amplifier I use in the IQ+Pro. This chip costs only this chip costs almost $30. I can use a PHA1 for $1.50, but it has a 47 dBm output IP3 because I conceive the IQ+Pro as a good candidate also for terrestrial communication with an extraordinary immune capacity for interference. That is the mixer, okay? The local oscillator is not double, it's single, and you have the splitter 90 degrees, but it's a little bit different in the architecture from the previous. You have the conversions outside, and this mixer incorporates also an autocorrection for IM2, intermodulation product 2, quite is also good because that creates also problems in a certain way how the signals mix inside the mixer. Benefits in practice. Higher dynamic range enables simultaneous reception of weak lunar echoes and strong terrestrial signals without intermodulation. Improved linearity, reducing distortions in complex modulations schemas, like digital, for example. Cleaner spectral purity. The IQ+Pro can be also used as a laboratory instrument in 144, as a top-notch spectrum analyzer in just a specific band where it is created, okay? Better signal-to-noise ratio margin. Well, the lower the noise, enhanced wave signals decoding reliability, especially under Faraday rotation. In short, the IQ+ moved from a sensitive lab-grade receiver to a precision instrument class front end. You can do, I'm sure, much more of this. I test already the latest prototype in HB9Q, and we are simple over the moon with this new improvement. That means we are looking forward to start producing the radio. Practical demonstration. Let me see, I just want to see. Okay, future plans we will talk about. I will do now a demonstration with this piece of software to show you what means a CW signal coming with a lot of flutter and QSB and man-made noise and LED lamps and photovoltaic inverters close to the antenna. And we will see what happens when we are changing a little bit the polarization of the antenna. We will see, for example, I introduced a configuration where you can see how the IQ+Pro with these characteristics will respond to this kind of interference, okay? You will hear the CW of the speakers. I will be seated here watching my computer. Just 1 minute, please. By the way, the software will be available, is already available on my homepage, and it can be downloaded. I need to do some initial configurations, okay? Because my presets are wrong. And as I said, I have probably a lot of bugs. I didn't have the time to correct nothing, okay? First of all, in polarization, let's go, I will describe a little bit. Oh, what happened? Yeah, okay, it's there. Yeah, okay. I will explain it a little bit. Here, the polarization, I can change TX and RX polarization 0, 45, 90, 135. I can auto-align. I can change the signal to noise ratio in 2500 Hertz. I can change my FFT and receiver bandwidth. I can change the auto filter up to 50 Hertz. In the upper part, you will see in the upper part, in propagation, I can induce QSV fading, I can induce flutter, I can induce Doppler drift, I can induce libration in hertz. In the interference, I can create man-made noise, LID, on photovoltaics. I can create hum noise sidebands. I can create pulse noise, killing all digital. These spikes, horizontal lines with your waterfall. I can simulate high dynamic range receivers, and then we have here an area where I will configure high dynamic range mode with ADC overloads, and we can see intermodulation interference, how affect radios with maximum 18-bit sample ADCs, and how 24 bits react on that. That means the first thing we do is let's go produce some output. This is a minus 10 dB signal to noise ratio. CW realistic signal is around minus 80 dB in a 2500 Hertz. Do you hear? Okay. No filter. No filter. No? No filter at the moment. I will introduce a 100 Hertz filter. Okay? And guys, no interference. This is pure synthetic. This never exists. Here is no liberation, no atmospheric noise, nothing. This is the dream signal. Okay? Let's go starting to kill the signal slowly. And look the polarization, please. It's still at 0 degrees both. Hey, super. We are not in a wrong polarization. Let's go introduce QSB fade. Not so aggressive. You see the change of the waterfall. That was the signal before. You still listen. But the polarization is perfect at the moment. That means it's just going deep. I can increase. I can increase the deepness. And we still in match polarization. I will add fluttering. I remove the deep QSB because I want to see the amount of fluttering. I'm not 100% familiar. Yeah. Now I add the QSB again. You hear something?
Yeah. Yeah.
Still?
Yeah.
Good ears. This is for testing, guys. Guys, this is forget it, the IQ+Pro 1 minute, please. This is a fantastic tool for learning, for teaching, for show your friends, to discuss with your friends on your club or whatsoever. Anyway, but the signal is still there. This looks much more pretty what is a CW signal, okay? And the polarization is still 0. If I move the polarization to 45 degrees, polarization is much, 45 degrees. Still there, because 45 degrees, the attenuation is just 3 degrees. Now let's go normally in 144 the mismatch polarization is around 75 degrees. This is still there? I don't think so. It disappeared on the waterfall. And we are not at 90 degrees. At 90 degrees the attenuation is infinite. Okay? Now, imagine you are running with Lucky at 45 degrees, mismatch polarization. Okay? And you have the QSB, yeah, probably, yeah, it's coming the signal. Still there, I heard. I will give a little bit better signal. Let's go and see, not minus 18 dB signal to noise ratio. Let's go give something like minus 14. The QSB is killing us. QSB associated with fluttering doesn't allow that. That's why, this is why a QSO could take half hour, because you pick up just one single letter in the precise moment you have this peak, and you lose the next one. Okay, and then you need another cycle, you need another cycle and another cycle, and then you complete the QSO slowly completing letters, numbers, etc. Now, guys, you live in a shitty place, your neighbor have a lot of Chinese crap, and they have these horrible LED lamps around. I activate the LED simulation. These are algorithms I download from the internet, how to simulate in fast Fourier transform. That means it's a real, and it's a synthetic. My disclaimer is here. Disclaimer, all propagations, interference, and receiver effects are synthetic approximations for educational purposes, and in the practice could be even worse, okay? And this is an electric interference in a very weak signal. Your signal is gone. You are toast. Forget about lobes, forget about antennas, forget about preamps. This is done by a $20 device, 50 or 100 meters from your antenna. And this is the kind of noise. Now, you are a person who likes to be responsible and green, and you add a photovoltaic inversors. And you have the up and down oscillation from the photovoltaic, typical photovoltaic interference. What can you do in this kind of interference? How you can mitigate? That's why 5 or 6 years ago, we have an exodus from 2 meters to 23 centimeters. And this is why today the 2-meter band is almost empty. People is there. Someone's still doing JT instead of Q65. Well, it's the choice. Okay? That means let's go back to our synthetic simulations without. Okay. I will back to 0 degrees. Okay, and I will. Signal is there. Okay. Now let's go and see, for example, we can add 51 to 100 hum noise, bad ground in your system. You didn't make a good electric installation, and you have hum noise in your station. This is also can be modulated. And let's go at pulse noise, the killer. That is, those who operate 2 meters, we know very well this kind of interference. And that kills your decodes immediately. That period is lost. Not CW. The CW you can still. The CW penetrate pulse better than digital. Okay? And let's go back a little bit to the normal. I can change the pulse range. I can make much more aggressive. I can change. I can add birdies, additional birdies, okay? I can add high-level birdies also, because you have a lot of switching power supplies, etc. And one last but not least, for example, we can simulate also what happened when you use a local oscillator with so much phase noise. This is something people doesn't understand really. And the phase noise could be in your local oscillator or in the local oscillator of the offender. But the characteristic and the error of the signal is always this one. You will see, I need to find phase noise here. You see now the signal is not anymore narrow. The signal has a component while I can expand. Nevertheless, the signal is still there. The signal is still there. Phase noise affects more digital than CW. CW is a little bit more immune. Still there. And I am gentle with the depolarization, guys. We're still at 0 degrees. Here we can simulate a station transmitting at 45 and receiving at 135. We can simulate Earth, north, south, east, west, any position. Okay? And then, last but not least, what I will do is I will reset all the effects. I will add some flutter. Now we are introducing, okay, I already activate intermodulation, okay. This is an 18-bit, no, sorry, 16-bit software-defined radio with a certain fixed intermodulation IM3 products attacking your setup. I don't know this one could be generated in your preamp or in the IQ+, but that's the level. Now, I will change from 16 bits to the IQ+ Pro running at 24 bits. The intermodulation is still there, but it's not clipping. It's not saturated. The internal preamplifier in the IQ+ is not saturated. The IQ mixer is not saturated. The post-conversion amplifier is not saturated. The ADC is not saturated. The intermodulation is still there. The signal is still here. Okay? And we can do also.
Go back to 16 bits again.
Sorry?
Can you go back to 16 bits?
Yes.
Again? Yeah, thank you.
Yeah, that means then we have some predefined, that is not a presets. That means take a little bit time to really find the real, because all this is fake, guys. This is synthetic, but it's a very good approach. It's a very good approach to understand what is the effect of the phase noise, intermodulation, fading, etc. For sure, what we can do is, I will tell you, I will present all the effects, and I will tell you just 1 minute. Yeah, more or less. Welcome to the echo in HB9. This is our echo. With 1 kilowatt on the antenna, 15 meter dish. That is optimal. And here, even with this amount of antenna, you can read below. The sharpness is not so good, but here you can read the characteristics. Okay. This is the attenuation at 45 degrees. This is when we are 90 degrees depolarized. Even an S9 signal, if you are 90 degrees away, gone. Okay? To finish, just 1 minute, please. Just 2 minutes. Go quickly. Okay. Future plans. Actually, we have 31 pre-orders. Mike, how many years we are in this exercise of the IQ+Pro? Remember, because you are one of the enthusiasts.
Almost 15.
Yes, but waiting the IQ+Pro?
Oh, that exercise.
5 years. And unfortunately, pandemia, that means COVID, disturbed all my job. I changed 3 times some parts because they become not anymore available or difficult to find. I lost in COVID, I lost all my family. I lost my father, my mother, my sister, and my brother. And that created a huge emotional toll on my life. That means I've been away for all this stuff for almost 2 years. But then I recovered my nerves, and here we are again. In between, 31 people commit to order the radio. The last prototype confirmed the repeatability and performance. This is what I chose. It will just one and unique batch, 40 units. Because guys, I have 25 years dedicated to produce stuff. Now I am starting to build preamplifiers with a completely, you will see tomorrow my presentation. Soon I will start to build some 10 gigahertz stuff coming, very, very cool. I don't want to give more information about yet. In a certain point, I want to stop building for you and start to build it for me. Okay? That will be when I retire, and it's coming very fast. That will be time for me. But I will be available always in this case. No? One means is a single batch. It will not be a regular production. 40 units we are sold, and then it's gone. That means 31 pre-orders. If you want to be inside the 40s, you can pre-order your radio, and the mechanic will be, I will work different. This exercise, to produce these 40 radios, I need to invest probably 50Ks, okay? And this is a lot of money, and this time I will be different. The pre-order will come with an official order with 50% pay in advance, and 3 months later you have your radio. And it's in between is my reputation of the last 30-something years speak by me, and it's not a problem. Yeah, this was questions. Go ahead.
Okay. Let's go into the digital world where people use MAP65 or QMAP or whatever. I have lots of experience at 144, and I have an X-Pulse system. What I can tell you is if you go to 45 degrees polarization, you lose 3 dB on the signal. It's the theory, it's the simple matter. Unfortunately, MAP65, because the larger FFT bin size, because it's processing over a very wide bandwidth, actually has nearly 2 dB worse threshold than WSJT-x.
Yes.
So that therefore, for remote, I run my dual transverter into an Elecraft K3, which I would challenge him for dynamic range of a transverter plus an Elecraft K3 very strongly, and I can remote both channels of the audio, and I can process the audio for whatever song. And the worst ever case I get, because MAP65 and QMAP aren't as good as WSJT-x or earlier's, that you actually only ever lose 1 dB at the worst polarization.
Thank you, John.
Totally in agree with what John said. That is because unfortunately we lost one of the great developers in MAP65. It was Bill, I think so his name, I don't remember the calls, and he passed away when we was improving MAP65, and John addressed one of the problems. My IQ+Pro simulator is the foundation of what will be DRI. And the evolution of DRI will be DRI MAP65. That means people is fighting with Linrad, what is very difficult to manage. I already have a software to manage Linrad with a Windows GUI. It works fantastic. But the simulator is the foundation to create a new MAP65, what will be embedded Linrad behind. And you will not notice, you will don't need to deal with any Linrad comment, and the problematic John address will be corrected. How we fix this one in HB9Q? In HB9Q, we have a Linrad master, and we have 4 Linrad slaves. I did this presentation in another EME conference, an optimized polarization receiver. We have 4 in each different angle, and we have 4 WSJTs. And we receive the full path of the signals in 4 different angles, and we answer in any of the signals. It's very complex, you need a powerful computer, and MAP65 is the panoramic receiver with the limitation John mentioned, but this limitation, it's coming to be away soon.
Thank you very much, Alex.